Welcome to video 8.3a, Triangle Similarity Theorems. So here's the three triangle similarity theorems. The first one's angle-angle similarity, then side-angle-side similarity, and side-side-side similarity. Note that angle-angle triangle similarity is the most commonly used one. All right, so for angle-angle, basically if you've got two angles of one triangle congruent to two angles of another triangle, then the angles are similar. For SAS, as long as you've got one angle sandwiched between two sides that are proportional, then you're going to get SAS. So here's an example. This angle is congruent to this angle. This side and this side are in the same proportion as this side to that side. The scale factor is K. So for a concrete example, 40 degrees, sandwiched between a 5 and a 10 and a 3 and a 6, both with a doubling scale factor. And finally, side, side, side. So that one involves no angles whatsoever, just all three corresponding sides being proportional. So side x, y, z, and side kx, ky, kz, those are going to be similar. So example 1, 2, 3, 2, 4, 6, again the doubling factor. Okay, so here's our first example. Example 1. Given parallelogram ABCD, prove that triangle BFE, so that's going to be this triangle here, is similar, not congruent, similar to triangle CFD. And that's going to be that triangle there. Okay. So the first thing I look at is automatically I've got those vertical angles. So without batting an eye, I will mark those. Okay, if I can get one more pair of angles, and again angle is the most common one, game over. Oh, they said that ABCD is a parallelogram. So that means this side is parallel to this side. I could have done other ones, but that's going to be the more interesting one. And then if I got those two sides parallel, I've got two different transversals I can look at. I'll just look at this transversal right here. For this transversal right here, notice I've got this Z formation, and when I've got that, that's alternate interior angles. So this angle here will be congruent to this angle there. Boom! This triangle will then be similar to that triangle by angle-angle similarity. Now that I've got a game plan, I'm going to write it all down. Okay, starting with the parallel. So ABCD is a parallelogram given. Based on that, I got these two sides to be parallel. So DC parallel to AB. If parallelogram, then opposite sides parallel. If parallelogram, then opposite sides parallel. And based on the parallel, that's how I got these two angles here. So I'll say angle DCF is congruent, I'll call it, to angle EBF. If parallel, then alt interior angles congruent. And what I like to do is just put a little A there. That's the first A in angle-angle. Then I could get the vertical. Of course, I could have done alternate interior again there, but just the vertical angles is so obvious, so I always tend to use that. Angle, what should I call it? I'll go CFD is congruent to angle BFE. If vertical angles, then congruent. So now I've got my two angles being established congruent. Now I can go to the final statement. triangle BFE is similar to triangle CFD. And what I want to emphasize is I'm going to write angle, angle with the tilde. Angle, angle, similarity. Again, when you use SAS and SSS for similarity, you've got to include that tilde so we know you don't think it's the congruence for triangles, but rather the similarity. So there you have it, the 3 triangle similarity theorems in one quick example.